Please welcome to the stage Rob McCaffrey, Editorial Director, Global Sales.
So, good morning everybody. Thanks very much indeed for coming along to the presentation this morning. The PCA asked me to come along and speak about the US cement industry in the wider context, and I'm reading The Art of the Deal by Donald Trump at the moment. It's a great book. If you haven't, who here has read that book? Put your hand up. Just a few people. You should all read it. You should definitely all read it. It's fascinating, and it's a good read as well. But Donald says, if you're thinking, you may as well think big. So I've decided to think really big. So I'm going to put the US cement industry in the wider context of the entire history of the universe, okay? They've only given me 20 minutes for this presentation, so I better crack on. So 14.6 billion years ago, the universe was created in a big bang, created all matter, all energy, and this matter eventually coalesced into dust, into stars, and very quickly after the Big Bang, within about 300 million years, into galaxies. If you don't like this origin story, then other origin stories are available. But if you look out at today's universe, you'll see up to 2 trillion galaxies and up to 200 billion trillion stars. And 200 billion trillion is more than all of the grains of sand on the entire planet Earth. Now, the Hubble Space Telescope looked out very famously a few years ago, and it looked at a tiny area which is equivalent to 1 grain of sand held at arm's length, a very, very small area. And it came up with this very, very famous photograph called the Hubble Deep Field. And actually, they counted up the number of galaxies that were in that tiny space. And it was 10,000 galaxies. And so if you imagine that number of galaxies spread over the entire sky, that's how you get up to 2 trillion galaxies. So there's a lot of galaxies out there and a lot of stars. So our particular local area of the universe is called the Laniakea supercluster, and Laniakea is Hawaiian for immense heaven. And just in our relatively local area, there are about 100,000 galaxies. But if you look even more closely at our local group, if you like, in that blue square, you'll see that there are 3 main galaxies. There's the Triangulum galaxy, the Andromeda galaxy, which is the furthest thing away that you can see with your own naked eye. And who here has seen the naked... Who here has seen the Andromeda galaxy with a naked eye or a telescope or binoculars? Who's seen the Andromeda galaxy? A few stargazers here. Yeah, it is fantastic. It's 2.5 million light years away. And then you come much, much closer, and there's our own galaxy, the Milky Way. And in fact, our galaxy has its own satellite galaxies. There's about 47, 48 other galaxies that are orbiting our Milky Way. So let's have a closer look at our home galaxy, the Milky Way. We are here on the Orion Spur, which is halfway between the Sagittarius arm and the Perseus arm. And our galaxy is around 13.6 billion years old. It's a pretty old galaxy. It came into being only about 1 billion years after that Big Bang. And the Milky Way has around 100 billion stars in it. And it's estimated now that 94% of them have planets. So you can do your own calculations. If only 1 in a million of those stars and their planets have life on them, there's still a lot of life out there. And I'm absolutely convinced that we are not alone. Let's zoom in on even more on our local solar system. Our solar system came into being around 4.6 billion years ago. Here we have a little picture of the solar system. It's obviously not to scale. There's the sun, which contains 99.8% of all of the mass in the solar system. So the moons and the planets is a very, very minor part of the entire solar system. And here we are, Mercury, Venus, Earth, that's us, of course. Mars, Jupiter, Saturn, Uranus, Neptune, and poor old Pluto, no longer a planet. Here we are on the Earth, came into being around 4.5 billion years ago. The interior of the planet is largely molten apart from the solid inner core, and we are all just floating around on the solidified crust, a very, very thin layer on top of that molten interior. And during the formation of the planet, the heaviest elements sank into the interior of the planet. That's iron and nickel, and some of those other elements, the lighter elements, the aluminium, silicon, and calcium, they were enriched in the crust, which is great because, of course, we use those for making cement. Now, life arose fairly quickly on the planet after it was formed. I personally think it was probably seeded from space rocks, because I feel that life is ubiquitous around the universe. And through the power of evolution and natural selection, we've arrived 4 billion years later, around 200,000 years ago, with our own species, Homo sapiens sapiens. And interestingly, our forebears arose in East Africa, as I say, around 200,000 years ago, and ever since we've been on the move. So the suggestion is that we moved out of Africa into Arabia, into the Eastern Mediterranean region, into Europe, into Asia, into Australia, and then finally, about 20,000 years ago, via the Bering Strait land bridge, we actually colonized first North and then South America. So in one way or another, we are all immigrants. Now, I want to start looking at the last 10,000 years, and interestingly, this is where we start seeing construction materials. So clay and lime were combined to form self-hardening materials that we use to construct floors, foundations, and walls in the Balkans and the Middle East from around 7,000 years ago. So you've got a little bit of construction industry right there. And during the last 10,000 years, a number of notable civilizations have arisen, including in Mesopotamia, ancient Egypt, in the Indus Valley, in ancient Egypt, in the pre-Columbian Americas, and of course in ancient Greece and in the Roman Empire. Many empires, many empires have arisen in that time, and many of them have fallen. It's always very, very instructive to remember that Portugal, about 300 years ago, had the world's largest empire, and it doesn't have it now. 2,000 years ago, something absolutely vital for us happened, and that was that the Romans found that by mixing burned limestone, sand, and natural pozzolanic material from volcanic deposits, they could make a strong binder, which we now call Roman cement. And they used that Roman cement to make some extraordinary structures, including the Colosseum and the Pantheon, which are still standing today and still absolutely spectacular today. But the secret of Roman cement was lost for many, many centuries, until around the 1750s, when during his research for the building of the Eddystone Lighthouse, the British engineer John Smeaton rediscovered the secrets of Roman cement. And in fact, that was the start of a period of innovation in the cement industry, which gave rise to an improved Roman cement, which we, of course, now call ordinary Portland cement. And that improved from the 1750s right through to the 1880s via Smeaton himself, via Aspdin, via Louis Vicard, famous French chemist, and others. And by the 1880s, rotary kilns had started to be used for the manufacture of cement, a far superior cement compared to what could be produced from the old vertical kilns. And then from the 1990s, a number of different companies, American companies, for example, Fuller, Danish FLS, and German KHD Humboldt Vedag, started to innovate to improve this ordinary Portland cement. And they were joined eventually by a number of other English, French, Belgian, and Japanese technology suppliers, and they essentially have created over the years this vast network of technology suppliers, which we see so very well represented at the IEEE this year. Development of modern cement companies, well, that really started way back in the early 1900s, where some national companies then went out and started either building or buying companies and cement plants in other countries, and they were the first multinationals. So the UK's Blue Circle Cement was the first multinational with its investments in South Africa and Canada, starting in 1912. Switzerland's Holderbank, a cement company, now of course Holcim, had early investments in Belgium and the Netherlands, and several other companies were also quick off the blocks to become multinationals, including France's Lafarge, Germany's Heidelberger Zement, now Heidelberg Materials, and Mexico's Cemex, and various others as well. And the critical thing to remember is, of course, that multinationals love to consume each other. So Blue Circle, which was an extraordinarily large and multinational company in its own right, was eventually eaten by Lafarge. Lafarge, if you like, was then eaten by Holcim. It was supposed to be a merger, but it didn't quite turn out like that. And who knows what's next? I've seen an article recently suggesting that Holcim and Heidelberg Materials should merge. Quite a strong argument for that. I absolutely don't see that happening anytime soon. And here we are looking at today's global cement industry. So clinker is produced in the vast majority of the world's countries. There's only a very, very few countries now that don't have clinker production capacity. But the fact is that today's global cement industry is massively dominated by China and by Chinese cement companies. And I have to tell you now that if you want all of these slides, you only need to go to cement2050.com and you'll be able to download all of these slides. So it's cement2050.com. So looking at today's global cement industry, 5 of the largest cement companies in the world are Chinese, and there they are: CMBM, Anhui Conch, CRBMT. Anybody heard of that company before? Nope. One of the biggest cement companies in the world. Taiwan Cement and Sonoma, and then rounding out the top 10 are Holcim, Heidelberg Materials, Cemex, Ultratech out of India, and Votorantim from Brazil. But as I say, the global cement industry absolutely dominated by the Chinese. And here you see, and these are figures from the United States Geological Survey from 2014, global cement production. And the globe diameters is proportional to the market share, or the global market share, if you like. And so China is vastly bigger than everybody else. It has 48% of global cement production, 1,900 million tons, followed in second place by India with 450 million tons of cement production, and then Vietnam 110 million tons of cement production. And then finally, I get to mention America. The USA 2024 produced 86 million tons of cement for a 2.2% global market share. And then it's followed by Turkey, Iran, Brazil, Indonesia, Russia, and South Korea in the top 10. And I felt that it was very, very useful and interesting to ask who owns the US cement industry. And it's not an easy question to answer. It's very, very difficult, in fact. But our best suggestion pre the formation of AmRise later on this year, 1st of July, is that 59% of the US cement industry is owned by essentially European companies, 17% is owned by domestic companies, 15% by Mexican, 6% by Japan. So it's a difficult question to answer, but that's our best answer. Where is it? It's actually concentrated in the east of the country, with major manufacturing in Texas and also in California. But US cement demand is around 110 million tons. Production is 86 million tons in 2024. And the balance is in fact down to imports. And the largest importer is Turkey, followed in fact by Mexico with 2.3 million tons, Canada 2.1 million tons, and Vietnam 1.9 million tons. But of course these are pre-tariff numbers, so they could certainly shift around from 2024 to 2025. So here we are today. Essentially, the US cement industry is sitting here. We're all here right now, the present. That's it. Okay, let's start moving into the future now. And some people have asked me, okay, you're going to be giving a forecast? No way, I am not giving you any forecasts. Everything's a little bit yippy at the moment. So if you want a forecast, insert your own forecast here. But what I will do is I will give you some pointers for what I think is going to happen in the next 75 years to humankind. I'm going to go through these super quick. The world is going to become old. The population of China will halve. We're going to have a lot more renewable energy. General AI will have been achieved. We'll have commercial nuclear fusion. We'll have another agricultural revolution. By 2100, we'll have global warming of 3 degrees. Life will have been found on other planets and moons. Humanoid robots powered by AI will be common. We'll have had a manned mission to Mars. The first one, I think, will probably be one way. We'll have quantum smartphones in our pockets. Cancer will be entirely preventable and fully curable. And I also hope that we will see the end of dementia by 2100. California, unfortunately, will have experienced the big one, a big quake. We'll have had more pandemics in the next 75 years, without a doubt. Getting on to cement. Cement production will be less than a quarter of what it is today, less than 1 billion tons worldwide. And I think that alternative cements will be the norm. Okay, let's start looking into the deeper future, and I want to start looking at what's going to happen up to the year 3000, 975 years hence. I think that the ice caps will have been melting, and global sea rise will have swamped many global cities, including Miami, including New Orleans, and including New York City, as well as my hometown, if you like, London. I think in the next 975 years, some civilizations will have completely collapsed. And I think by the year 3000, other civilizations will also have risen. And global population is currently due to peak at 10.4 billion in the year 2086. But I think it will decrease, well, it's certain to decrease, but to an absolutely unknowable number in 975 years' time. Well, let's go into the deep, deep future. By the year 12,000, humanity has less than a 95% chance, less than a 5% chance of still existing, and 95% chance of being extinct. By the year 17,000, it's more likely than not that a civilization threatening supervolcano, for example, your own Yellowstone, will have erupted, spewing more than 1,000 billion tons of material into the atmosphere. By around 500,000 years into the future, it's more likely than not that the Earth will have been hit by a meteor of more than 1 kilometer in diameter. But don't worry, because the one that wiped out the dinosaurs was 15 kilometers in diameter, so it's only a small one. By 350 million years hence, all of the continents on the planet will have fused together into one huge supercontinent. But by 800 million years' time, the cooling of the Earth's core will have led to the end of plate tectonics, and the Earth will become a more or less flat, water-covered water world. So Kevin Costner was right. Let's start looking into the very deep future. In between 2 and 5 billion years' time, the trillion-star Andromeda galaxy will collide and coalesce with our own Milky Way galaxy. In about 7.9 billion years, the Sun will expand to the diameter of the Earth's orbit, and the Earth will be completely obliterated. During the period 100 billion to 1 trillion years' time, All of the 47 galaxies in our local group will coalesce into one big galaxy. And now, the very, very far future, the very, very deep future, 1 nonillion years' time. The fact is, by then, the supermassive black holes in the heart of all galaxies in the universe will have consumed everything around them. No more stars, no more planets, only black holes. And then, by 10,000 Googol's time, that's a really long time, even the largest black holes formed from the collision of multiple galaxies will have evaporated through the emission of radiation. And now we're starting to look at the end. Eventually, all objects will decay to subatomic particles, gradually winding down in the heat death of the universe to absolute zero. Like I said at the beginning, if you don't like this story, then there are other stories available. We are not here for long, so we must make the most of today. Folks, hang on, hold back. I like your enthusiasm, but wait. We're not here for long, so make the most of today. So folks, please, stay safe, be good, and if you can't be good, don't get caught. Thank you very much.